Hello students, in the last session we have discussed some of the questions from the chapter Carbon and its compounds. Today let us discuss some more questions from the same chapter. Already we have completed 12 questions. Now let us study the next question, that is question number 13. You can see here the given question is, question number 13 is, how many electrons are there in the outermost shell of carbon? The question is, how many electrons are there in the outermost shell of carbon? Dear students, the given options are 1, option B 2, option 3, C 3, option D 4. We know that the carbon which belongs to group 14th with the atomic number 6. Okay, the atomic number of carbon is 6. Now we know that 6 electrons and 6 protons are there in the carbon with the atomic number 6, means the electronic configuration here is 1s2. We know that the atomic number of carbon is 6 with the electronic configuration 1s2. That is the first main energy level contains only s orbital. The maximum capacity to hold the electrons for the s orbital is only 2. Next we have to consider here the second main energy level, that is the s orbital, contains 2 electrons. Now 1s2, 2s2, 6 electrons are there, remaining is 2 electron that enters into the second main energy level p orbital. That means we have to write here 2p2. And you can see here, dear students, the 6 electrons are there in the carbon, means the outermost electrons enters into, that is the 4 electrons enters into the second main energy level, and second main energy level here is the outermost main energy level, or it is also called as a valence shell. You can see the valence shell contains how many electrons? 4 electrons. Therefore, the answer for this question is the number of valence electrons or the outermost electron present in the carbon is 4. Dear students, we know that the p orbital has a maximum tendency to hold the 6 electrons, but here filling takes place in the first main energy level s orbital, second main energy level s orbital. 4 electrons are already filled, remaining 2 electrons enters into what? 2p orbital. Therefore, the second main energy level is the outermost main energy level. Valence shell contains 4 electrons. Now, question number 14. If you read that question, the given question is chlorine reacts with, dear students, they have given here the chlorine reacts with the saturated hydrocarbons. Already know the meaning of this saturated hydrocarbon, means always they contain carbon to carbon single bond. And we know that the carbon to carbon single bonded hydrocarbons, open chain compounds, if you consider, they're called as the alkanes. And we know that compared to the alkenes and alkynes, dear students, alkanes are least reactive hydrocarbons because they are in the saturated form, no pi electrons in that. Hence, saturated hydrocarbons undergoes the reaction, means the characteristic reaction we know always. Characteristic reaction of the saturated compound is a substitution reaction. Therefore, here whatever they have given, chlorine reacts with the saturated hydrocarbons at room temperature. Understood? At room temperature in the presence of saturated hydrocarbon they have given. I'll write one of the simplest example for the saturated hydrocarbon, that is the alkane I have written here, that is methane. Undergoes reaction with the chlorine, means dear students, no tendency to undergo the addition reaction. In the last session we have studied addition is the characteristic reaction of unsaturated. Therefore, here what happens? Substitution takes place. Substitution means replacement of a hydrogen atom by what? Chlorine atoms here. Such type of reaction always takes place in the presence of sunlight. Dear students, sunlight we can denote it by writing H nu also. That H nu is nothing but sunlight, presence of sunlight. And we know that substitution, hydrogen atom is replaced by chlorine, means CH4 becomes CH3 and bond is with what? Chlorine, along with the formation of the byproduct hydrogen chloride. Understood? Now this type of reaction is always called as a substitution reaction. Students, substitution is the characteristic reaction of what? Saturated compounds, that is a saturated hydrocarbons. Always the substitution takes place in the presence of what? Sunlight. Hope you have followed this. Let us check now question number 15. The question number 15 here is, listen now, electron dot structure of chlorine molecule is electron dot structure. Dear students, the electron dot structure is also called as a Lewis dot structure. Who observed this structure for the first time, a scientist called Lewis. Therefore, it is also called as a Lewis dot structure. This structure, that is the electron dot structure of a chlorine molecule. They have given here chlorine molecule. That means 2 chlorine atoms are there. Dear students, if you consider the chlorine atom, okay, if you consider the chlorine atom, now we know that the chlorine with the symbol capital C and small l has the atomic number 17. Okay, if I write the electronic configuration of the chlorine, 1s2, 2s2, 2p6. Dear students, totally how many electrons we have written? 10 electrons we have written, isn't it? Then remaining 7 electrons enters into the third main energy level. First it enters into the s orbital of third main energy level, 3s2, and here it is the 3p. See, 12 electrons, 5 electrons. Understood, no, dear students? We have to write here the 5 electrons remains here. Okay, now if you consider the valence shell, that is the outermost main energy level, if you consider 3s2, 3p5, totally how many electrons are there in the outermost shell, which are called as a valence electrons? Valence shell contains how many electrons? 7 electrons, valence electrons. Dear students, you know that octet rule you have studied, isn't it? Octet rule, that means atom of any element, if you consider, always it tries to attain completely filled outermost shell, that is a noble gas configuration, which is a highly comfortable state for that atom. Comfortable is nothing but a stable. That state is called as the octet state. Hence, you can see here in the chlorine atom, 7 electrons are there. If it gets one more electron, one extra electron, it can reach what? Octet state. That is the more comfortable state, that is called as a noble gas configuration or completely filled outer electronic configuration. Therefore, the chlorine atom shares its electron. Understood? It do not have any tendency to gain extra electron, means sharing takes place here. It gains the electron. Understood? It has a tendency to gain the electron if any atom is ready to donate it. But here they have asked about chlorine molecule. Therefore, 2 chlorine atoms to attain the stable state, they readily shares their electrons. Now, 1 chlorine atom, if I consider, totally how many valence electrons? See, 7 electrons we have written. Totally 7 electrons are there. 6 I have written, 3 pass, and 1 more I'll write it here. This is also the chlorine atom containing how many electrons? 7 electrons. That is the valence shell contains 7 electrons. Now, what happens? In order to reach the highly comfortable state, sharing takes place like this. See here. Now, this chlorine atom gains the electron from the another chlorine atom. Again, the sharing of electron takes place like this. And you can see here, dear students, during this process, sharing process, how many electrons get shared here? 2 electrons. That means 2 electron, nothing but a pair of electron, means always it results in the formation of a single bond between what? Chlorine atoms. In the formation of chlorine molecule, a single bond means always it has to involve how many electrons? 2 electrons. Students, you can see here, totally this chlorine, after the sharing of electrons, this chlorine has got 8 electrons, and after the sharing, this chlorine also has got how many electrons? 8 electrons. That means it can reach which state? Octet state, highly comfortable state, nothing but a stable state. That is also called as a noble gas configuration. Now, if you observe the structure they have given, dear students, option A, if you consider the option A, totally how many electrons are there? 2, 4, 6. And sharing here, 2 pairs gets shared here. That means 2 electrons from this, 2 electrons from this. If I add this to the 6 electrons, totally 10 electrons are there. But always an atom of the element tries to attain which state? Octet state. Hence, this is not the correct structure. And if you consider the option B here, structure you can observe 2, 4, 6 and 2 electrons are shared, means totally for this chlorine 8 electrons, for this also 8 electrons. And you can observe here, dear students, this is the correct structure of the chlorine molecule. Sharing results in the formation of which bond? Covalent bond. Okay, it results in the formation of a covalent bond. Clear now, dear students? Hope you have followed this. Other 2 structures also you can check. If you know the atomic number, easily you can find out what the correct structure of what particular molecule. Now I'll consider question number 16. Question number 16. Let us check. Question number 16 here. Dear students, the given question is the number of carbon atoms present in the molecule of a fifth member of the homologous series of alkyne is. The number of carbon atoms present in the molecule of fifth member of the homologous series of what they have given? Alkyne they have given. Dear students, you know the general formula of alkyne. General formula of alkyne is a CnH2n minus 2. The first member has to contain how many carbons? We know that alkynes are nothing but unsaturated compounds. Unsaturated means always it has to contain carbon to carbon triple bond. Triple bond is always present between two carbons. Therefore, the simplest member of alkyne means it always has to contain how many carbons? Two carbons. Thus, this is the first member. C2H. 2 into 2 is 4 minus 2 becomes 2 only. This is the first member. If I consider the second member, dear students, C3 and H4. This is the second member. And if I consider the third member, C4. And here it is a H6. See, 4 into 2 is 8. 8 minus 2 is a 6. If I consider the fourth member, it contains how many carbons? 5 carbons. Okay, hydrogen you can write here. Hydrogen number is 8. If I consider the sixth member, fifth one. See, 1, 2, 3, 4 and fifth one if I consider. C6. How many carbons are there in the fifth member of the alkyne homologous series? 6 carbons are there because first member starts from 2 carbons. Therefore, C6. And if I write the C6 here, H10 I have to write. Understood, no, dear students? This is the first member of the alkyne. This is the second member. This is the third member. And this is the fourth member of the alkyne series. And this is the fifth member of the alkyne series. You can see here, fifth member contains how many carbons, dear students? 6 carbons. 6 is the correct answer because the first member starts from the molecular formula C2H2. Hope you have followed this. Let us study now the next question. Question number 17. See what they have given in the question number 17. IUPAC name of one of the compound they have given. Okay. The compound, given compound here is, dear students, if you observe this question, the given compound is CH3, CH2, 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 COOH. Now we know that IUPAC name, we have to start from the prefix part, but no prefixes in this. It contains only carbon and hydrogen along with the functional group. Therefore, we have to start from the root word. How many carbons are there in this parent chain? You can count, isn't it? Totally how many carbons? 5 carbons are there. That is the root word we have to write here is, dear students, pent. And if you check the type of bonding between the carbon atoms, type of bonding between the carbon atoms. Type of bonding means, you can see here single bond, carbon to carbon single bond is there. Carbon to carbon single bond means always the primary suffix we have to use is ANE. Isn't it? E I have not written because it contains a functional group. You can see the function group here. The function group present in this is a COOH group. COOH means a carboxylic acid compound. What is the secondary suffix we have to use? We know that, dear student, the secondary suffix we have to use here is oic acid. Isn't it? Secondary suffix we have to use here is oic acid. Now, oic acid first letter is a vowel. Therefore, the end letter of the primary suffix ANE is replaced by what? The secondary suffix, nothing but oic acid. What is the IUPAC name of this compound? Pentanoic acid. Understood? Dear students, if I consider first option, pentanal. Al stands for aldehyde. It is not the correct option. Second option, if I consider pentene, you can see here, pent is there, root word is correct. But what they are given? En. En means, dear students, we know that primary suffix En means in. Carbon-carbon bond should be which one? Double bond. Any one of the position it has to contain a double bond. But there is no double bond here. Therefore, it is not in. It is a ane. Understood? Pentanoic acid. This is not pentanoic acid. Pentanone they have given. ONE stands for a ketonic compound. Function group of a ketone is CO group. Hence, this is also not the correct option. Correct option here is a pentanoic acid. Okay, students? Now, let us check question number 18. Dear students, the question number 18 here is the allotropic form of carbon, which is smooth and slippery is. We know that the carbon exists in three different allotropic forms, isn't it? It has got three different allotropes. What is the meaning of allotropes? What are allotropes? Dear students, allotrope is nothing but an element having the tendency to exist in different forms, having the different physical properties. Main condition, allotropes always have got a different physical properties, but in some cases the chemical properties also changes, and we know that the one of the allotropic form of the carbon is a diamond. It's given here, diamond. And another allotropic form of a carbon is a graphite, and one more allotropic form of the carbon is a fullerene. Okay, dear students, now if you consider the carbon, graphite and fullerene, all these contains the same element. Which element? That is the carbon only. Element present here is the carbon only. But dear students, among this diamond, if I consider, it is the hardest allotrope of carbon. If the question is, which is the hardest allotropic form of carbon, means you have to write what? Diamond, because the hardest allotropic form, because of its structure, okay, because of its rigid structure, it is very hard. And if you consider the graphite, dear students, we know that the graphite is one of the allotropic form which is very smooth and slippery because of a weak force of attraction between the layers of different carbon atoms here. That means in between the layers, a weak force of attraction exists. Because of that, it shows a slippery nature. That means the allotropic form of carbon, which is smooth and slippery, means we have to consider which one? Graphite. One more allotropic form is there here. That is the fullerene. Now, dear student, the fullerene is also the allotropic form only. And if you consider the carbon 60, option D. What is this carbon 60? Carbon 60 is also one of the form of a fullerene only. Carbon 60 is a first identified fullerene, that is the carbon 60. Therefore, these two are same. Option B and option D, fullerenes only. This is the first identified fullerene, carbon 60, which has got a football shape. It is also called as a Buckminster fullerene. This carbon 60 is also called what? Buckminster fullerene. Therefore, these two are fullerenes, and diamond very hard, graphite is smooth, and it is a slippery in nature. Because of that, we can use what? This graphite can be used in what? Eraser also, because the layers can be removed easily. Understood? In the eraser, we can remove whatever we write by using the pencil. Pencil is nothing but a graphite only. That is because of the presence of what? Weak force of attraction between the layers. Understood, dear students? Now, let us consider question number 19. Now, question number 19, if you consider, if the molecular mass increases in a homologous series, the molecular mass increases in a homologous series of carbon compounds, then MP, what is that MP? Melting point and boiling point increases. Option B, melting point and boiling point decreases. Option C, no change in melting point and a boiling point. Option D, melting point increases and boiling point decreases. Understood? Now, if the molecular mass increases in a homologous series, see here they have given the molecular mass increases in the homologous series they are given. What happens to the melting point and boiling point? Listen here, students. In order to study this, let us consider the simple homologous series, simplest homologous series. I'll write, we have discussed this type of question in the last session also. Somewhat related to this, but different type of questions. Listen here, C4CH4, that is a methane. Next I'll write C2H6 ethane. Next I'll write C3H8, that is a propane. Next I'll write C4H10, that is a butane. Dear students, if you consider these members, okay, what happens here? The number of carbon atom increased by 1 unit, number of hydrogen atom increased by 2 units, isn't it? That means from here to here, number of carbon and number of hydrogen increases, means the molecular mass always increases. Dear students, molecular mass always increases. Now, what happens once the molecular mass increases? Listen here, students. Molecular mass increases only due to the increase in the number of atoms. Understood? As the number of atoms increases, if I write the size of methane is this, for example, okay? Only for example, I'll consider if the size of methane is this. Ethane, 1 carbon and 2 hydrogen increases means size increases. Understood? Propane, again from ethane to propane, 1 carbon, 1 hydrogen increases means again the size what happens? Increases. Dear students, size increases as, okay, number of atoms increases. Therefore, the molecular mass anyway it is increases. Now, what happens as the size increases? Surface area increases. Understood? Surface area increases. Because of the increase in the surface area, intermolecular force of attraction. Which force of attraction exists here? Dear students, already we know it is the van der Waals force of attraction. Isn't it? Van der Waals force of attraction between the molecules, intermolecular force of attraction, what happens? Increases. Here also, a large number of molecules can come and attract this molecule. That means the van der Waals force of attraction, what happens? Increases. We know that, dear students, boiling point is the temperature at which all the force of attraction has to break. Molecule has to remain in a free state. Each and every molecule has to remain in which state? Free state. Therefore, as the van der Waals force of attraction increases due to the increase in the surface area as the size increases, the energy required to break that, okay, temperature required to break that van der Waals force of attraction also what happens? Increases, because molecule should be in which state? Free state, in order to get converted into the liquid to vapor state. Hence, as the molecular mass increases, surface area increases, van der Waals force of attraction increases, therefore the energy supplied should be higher to break the van der Waals force of attraction, therefore boiling point increases. Understood, dear students? Boiling point increases. Now, what about the melting point? As the molecular mass increases, melting point of the substance also what happens? Goes on increases. Therefore, answer for this question is melting point and boiling point increases with the increase in the molecular mass. Hope you have followed this. Okay, here the other option you can check, but the correct option here is option A. Correct option is option A, melting point and boiling point increases. Now let us check the next question. Dear students, let us check the next question. The question number 20th. What they have given in the question number 20th? Now bottom of cooking vessel getting blackened. Okay students, bottom of the cooking vessel gets blackened due to. Now the options they have given here is complete combustion, excess supply of oxygen, incomplete combustion. Now all are correct they have given. Dear students, we know that the cooking vessel, bottom portion of the cooking vessel gets blackened. This is only because of the incomplete combustion. Follow now, dear students, incomplete combustion. What is that incomplete combustion? We know that combustion reaction is nothing but a burning process. Okay, what is meant by combustion? Combustion is nothing but a burning reaction. Okay, burning reaction. Now, dear students, if you consider any of burning reaction always releases a large amount of energy in the form of light and heat. If the burning process takes place in the presence of a limited supply of oxygen, limited supply. Understood? If the combustion process takes place in the limited supply of oxygen, combustion will not be completed. That type of combustion is always called what? Incomplete combustion. Why this incomplete combustion takes place? Listen here students. If the air inlet for the supply of air, whatever the holes are there, if those holes, inlet for the air gets blocked, the supply of air becomes what? Limited. In such a case, fuel burns with the large amount of a smoke or a soot. It produces what? Large amount of smoke or a soot. Clear now, dear students? Now, because of the release of soot, or since it burns with a sooty flame, the bottom portion of the vessel becomes what? Black. Answer is, it is not due to the complete combustion. Complete combustion means always it produces a clear flame without any smoke or soot. Okay, hence option A is not the correct option. Excess supply of oxygen means always which type of combustion takes place? In the presence of excess supply of oxygen, always complete combustion takes place. Therefore, soot is formed because of the formation of carbon, nothing but incomplete combustion. Okay, option C is the correct option. Now let us check question number 21. Dear students, the question number 21 given question here is which of the following represents the correct structure of N2 molecule? Which of the following represents the correct structure of nitrogen molecule? Now if I consider the nitrogen, atomic number of nitrogen is 7. If I write the electronic configuration, 1s2, 2s2 and 4 electrons are over out of 7 filled. How many electrons remain here? 3 electrons. The outermost main energy level, second main energy level, nothing but a valence shell contains how many electrons, dear students? 5 electrons. These electrons are called as the valence electrons of the nitrogen. Now they have asked about the nitrogen molecule. Already we have studied about the structure of chlorine. Nitrogen molecule, if I consider, we know that each and every atom of an element always tend to attain which state? Octet state, or the completely filled outer electronic configuration state. Now in the outer shell, okay, second main energy level contains how many electrons? 5 electrons. I'll write those 5 electrons of one nitrogen atom. Okay, 5 electrons I have written. Now I'll write one more nitrogen atom. 5 electrons are there here, understood? But to reach the octet state, octa means 8 electron state, this nitrogen requires 3 more electrons. This nitrogen also requires 3 more electrons. Therefore, nitrogen atoms shares their electrons, understood? Sharing of electron takes place. How this sharing takes place? Now I'll write here, this nitrogen shares its electrons with the next nitrogen atom. 3 electron sharing takes place. And also this nitrogen shares its electrons with the next nitrogen atom. Dear students, totally how many pairs get shared here? 3 pairs. You can see here one of the pair in this, we can write here like this, one more pair and next pair. A single bond means how many electrons? 2 electrons. How many electrons are used here? 6 electrons. Therefore, dear students, the structure of nitrogen means 6 electrons gets shared, 1, 2, 3 and like this. Okay, this is the correct structure of what? Nitrogen. Nitrogen to nitrogen triple bond. Where you can see the nitrogen to nitrogen triple bond? Option B. Okay students, and option A, C, none of these they are given. You can check it. Structure already we know, that is the nitrogen to nitrogen triple bond is present in the nitrogen molecule. Question number 22. Which of the following statements are usually correct for carbon compounds? For the carbon compounds, which properties are correct properties? They were asked like that. Okay, the first property, if you observe, are good conductors of electricity. Is the carbon compounds or the covalent compounds are good conductors of electricity? No, carbon compounds are always a poor conductor of electricity. Poor conductor of electricity. Why they are poor conductor of electricity? Because the bond present here is a covalent bond. Because of the covalent bond, the charged particles are not formed. Because of the formation of the covalent bond, sharing of electrons, these compounds do not produce ions. Charged particles are not formed to carry the electrons for the generation or for the passage of electricity. There should be charged particles. No charged particles are released means it is always what? A poor conductor of electricity. Now that is the second option they have given. If you observe the second characteristic property they have given are poor conductor of electricity. Correct? No. Then have strong force of attraction between their molecules. Third characteristic property they have given. No, isn't it? Always they do not have strong force of attraction. Force of attraction between the molecules, intermolecular force of attraction is not strong. It is a very, very weak force of attraction. Which force of attraction? That is a force of attraction is a van der Waals force of attraction. Dear students, van der Waals force of attraction exists. It is a very weak force of attraction. Van der Waals force of attraction is a very, very weak force of attraction. Therefore, among the given properties, property second and property fourth are correct properties. Therefore, their question is Which of the following statements are usually correct? Which statements are correct? Second and fourth. Option D, second and fourth. Understood? Next, let us consider question number 23rd one. Now, vegetable oil generally have, dear students, we know that among animal fats and vegetable oils, among fats and oils, oils are usually good for health. Why these oils are good for health? Dear students, oil usually contain a type of fatty acids. It may be the oil or it may be the fat. Usually it contains what? Fatty acids. Now, what are fatty acids, dear students? Fatty acids are carboxylic acids only. Okay? Fatty acids are nothing but carboxylic acids. Clear now, dear students? Monocarboxylic acids, a single COH group is present with a long chain of carbon atoms. Long chain means if I consider any of the fatty acid, for example, if I consider the palmitic acid, dear students, if I consider palmitic acid, okay, this is a fatty acid. No need to study this for your reference. Palmitic acid means it contains 16 carbons. See 16. See here, long chain. Out of 16 carbons, one is of a carboxylic group. You know the formula of carboxylic group, COOH. Okay. Remaining 15 are there in that chain. A long chain is there here. 15 carbons means, if I write this as a first carbon, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13, 14, 15, 16 and 16th one. What is that 16th one? If I consider that as a carboxylic group. See, long chain is there. Long chain carboxylic acids are called what? Fatty acids. Understood? Now, vegetable oil usually contains the fatty acids with a long chain of carbon atoms at any one or more than one position. It contains what, students? Double bond. Understood? See, if I write here a double bond, is this chain is a saturated one? No. Which chain we have got here? If I write a double bond here, we have got which chain? Unsaturated chain. Understood, dear students? If the fatty acids contains an unsaturated carbon chain with a double bond like this, always it is called as a oil. If it contains a unsaturated carbon chain in the fatty acid, it is called what? Oil. The question is regarding the vegetable oil. Now, vegetable oil usually contains what? Long unsaturated carbon chain. It contains what? A long unsaturated. See, double bond is there. Palmitic acid means C16, H32 and O2. This is the formula of what? Palmitic acid. C16, H32, O2. 16 carbons are there. At one position, it contains what? Double bond. Therefore, it is called as a long carbon chain only with the carboxylic acid. How that long carbon chain exists? In the form of an unsaturated one, because at one of the position, it contains what, dear students? Double bond. Now, if I consider the animal fat is also fatty acid only. Okay, it is also fatty acid only. But the animal fat means the fatty acid, in that fatty acid, in the case of animal fats, the fatty acid contains what? Long chain carbon atoms only. Okay, along with the carboxylic group, it contains a long chain. How that long chain carbon atom exists? That long chain carbon atom exists in which form? A saturated form. Understood, dear students? It exists in which form? A saturated form. Stearic acid, if you consider, the 17 carbons are there. 17 carbons means it is in the saturated form. No double bond here. This is in the case of what? Both contains a fatty acids. But in the animal fat, the fatty acid is what? Saturated. That means it contains a long chain of carbons with the carbon to carbon single bond. Vegetable oil contains what? Unsaturated carbon chain. Dear students, unsaturated carbon chain is always, if a fatty acid contains unsaturated carbon chain, it is always good for health because this fatty acid has the tendency to control the cholesterol level, as well as if you use the vegetable oil, nothing but unsaturated carbon chain fatty acids. If you consider, if you use that for the cooking purpose, always it has a tendency to prevent heart related problems also. Therefore, always vegetable oils are good for what? Health compared to the animal fats. Animal fats means a saturated carbon chain. They contains a saturated long chain carbon in the fatty acid. Vegetable oil means a unsaturated long chain carbon in the fatty acid. Okay, dear students, therefore, our option here for the question is a long unsaturated carbon chain exists in vegetable oil. If it is an animal fat, long saturated carbon chain, single bonded carbon, saturated carbon chain exists. Hope you have followed today's explanation. The remaining questions of the same chapter, carbon and its compounds, let us discuss that in the next session. Thank you, dear students.
Thank you.